So we now need to get into the derivatives of our trigonometric functions. And the most basic functions to find our derivatives for are sine of x and cosine of x. So probably the best way to do that is to establish our limit by using to establish our derivative by using the limit definition itself to develop that. I'm going to do that using my sine of x function. So for sine of x, let's apply the formula right here. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So let's see what happens when we do this. Our derivative will be found by taking that limit as h is approaching 0 of the sine of x plus h minus the sine of x all divided by h. Well, now this may seem like a very strange thing. What could we do, right? As h approaches 0, by the way, this would be 0 over 0 by direct substitution, so that's not going to work. But that's by design. So what do we do? Well, what we need to do is we need to take this guy right here and break it apart. And so if you recall, there's a formula that says anytime that you have the sine of a sum of two angles A and B, then our definition tells us that it will be the same as taking the sine of that angle A times the cosine of that angle B and adding to it the cosine of the angle A times the sine of the angle B. So let's go back here. What are we going to do? We're going to get our limit as h is approaching 0 of the quantity sine of x times the cosine of h plus the cosine of x times the sine of h minus the sine of x. And we're going to do that all divided by h. Now, it seems like, okay, now how do I know what to do at this point? Well, I'll note that there's two of these terms right now that contain sine of x. And there's a reason why I might want to think about this, but we can use our special limits if you recall them for sine and cosine. And I'll show you how. Let's split this up, though. So I'm going to gather some terms. So I'm going to gather the limit as h approaches 0. And I'm going to make one term that looks like this. Sine of x times the cosine of h minus the sine of x. And I'm going to put that over h. Then I'm going to add to that the cosine of x times the sine of h divided by h. And it may not be obvious to you yet, but one more factorization should help. Let's go with that left term and take its limit as h goes to 0. If we take the limit as h approaches 0 of the quantity sine of x factored from the fraction cosine of h minus 1 divided by h. And I do a similar thing right here. I'm going to factor out cosine of x, and that's going to be multiplied by the sine of h divided by h. Well, that actually seems kind of familiar right there. Do you recall these? Well, I hope so, because if you remembered anything, you would remember that the limit as what was our quantity here? I think we just used x, but it doesn't matter. We'll call it t. The limit as t approaches 0. Yeah, it's supposed to be an arrow. The limit as t approaches 0 of the sine of t divided by t is equal to 1. And likewise, the limit as t approached 0 of 1 minus the cosine of t divided by t, that went to 0. So right here, even though this is in the wrong order, cosine of h minus 1, it's the negative of 1 minus cosine h over h. And we're taking that limit as h goes to 0. Well, just like the formula says, that's going to go to 0 whether we put a negative or positive in front of it. As far as the other term goes, sine of h over h is going to have a limit that goes to 1. So what are we left with? Well, we're left with the sine of x times 0 plus the cosine of x times 1. And therefore, if f of x is equal to sine of x, then f prime of x is going to equal to the cosine of x. Interesting. Okay, I'm going to leave this as an exercise. Verify using your limit identity, and this is an assignment. I want this turned in on your homework. Verify as an assignment that if f of x is equal to cosine of x, f prime of x actually ends up being the negative of the sine of x. All right, so there we go. Uh, that's homework. It's assigned. I expect you to turn it in. Verify that f prime of x equals sine of x using your derivative formula right here. F prime of x equals the limit as h approaches 0 of f of x plus h over f of x minus f of x all over h. Easy for me to say. All right, easier for you to do, right? Just kidding. I'll see you in class.